All right, so now we're evaluating each expression. So now's when we want to simplify or, kind of at least reduce to simplest terms, or we'll get these to simplest terms. So number 7, so I have 81 to the 1/4 power. So here's where your list of common powers comes in handy. So what you want to do is try to get the base into a list of common powers, or into into exponential form, I should say. So then, and you could convert this to a radical form and say the 4th root of 81, and then you could plug that into your calculator, or you could break it down this way. But I'm going to keep it in exponential form just for the purpose of this exercise, just to kind of show you, since they are exponents, how to work with exponents. So, but doing it this way is fine with me, as long as you can kind of show your work and justify your answer. So 81 is 3 to the 4th power. It's also 9 squared. Since I have a 4th fraction here, I'm going to get it to 3 to the 4th. That way the fraction will cancel out. So then I'll put the 1/4 back there. And so remember, this is the power rule. When I have a power raised to another power, I just multiply those exponents. So it's going to be 3 to the 4 times the 4th is just 1, right? And so it's 3 to the 1st, but I'm just going to leave that 1 out. So that's the answer. So that's another way to solve, or excuse me, this is another way to evaluate radical expressions. If you want, is you could go this way, convert to exponential form, and then simplify using exponents. Okay. All right, number 8, same thing. 8 is 2 cubed, right? So I'm going to convert this to 2 cubed. Then I'm going to bring down the exponent, and then we can multiply those exponents, right? So 5/3 times 3 is just 5, right? So 3 times 5/3 can make that 3 over 1. 3's cancel out, so we just end up with 5, right? You don't have to show that work, this is mental math. 2 to the 5th is 32, and that's it. All right, now number 9, here we have 27 to the 1/3 power multiplied by 27 to the 4/3. So one thing we can do with this is we can actually combine those exponents using the product rule, right? We can add the exponents because the bases are the same. So we get 1/3 times 4/3 is 5/3. And then we can simplify 27 to the 5/3 power can be simplified to, or actually let's simplify 27 first. Sorry, I got a little ahead of myself. So this would be 3 cubed, right? Just checking on my list of common powers. Okay, and then we just did 3 times 5/3 a minute ago. That turns into 5. So this will be 3 to the 5th, which equals, if I look at my list of common powers, that would be 243. All right. Now number 10, this one, tempting to want to do quotient rule because I'm dividing, but the bases are not the same, right? So 64 and 343 do not have the same base, so I can't just combine them that way. So what I can do a couple things, but what I'm going to do is just simplify the numerator, then just simplify the denominator. Okay, so I'm going to turn 64 into, since I'm dealing with thirds, I could do 4 to the 3rd, or I could do 2 to the 6th, either way. Okay, let's do 2 to the 6th. Okay, it's usually you can't go wrong by getting a smaller base and a bigger exponent with these problems. Now 343, I don't have much choice. That's 7 cubed. So now I'm going to put those exponents out there, the ones that were there in the first place, right? And now I'm just going to operate. So I'm going to multiply these exponents. So I'm going to have 2/3 times 6 is 4. And 2/3 times 3 is 2. Okay, so I have 2 to the 4th over 7 squared. 2 to the 4th is 16. 7 squared is 49. There are no common factors there. So that's fully reduced, and that's our final answer. All right, so that's how you simplify exponential expressions with rational exponents is try to get the bases in exponential form and then multiply the new exponent that you got by the fractional exponent, by the rational exponent, and that should simplify things, so you can go from there.